Uh, okay. Hi, in this particular video, we will be talking about additional features of HDLC, that is extended addressing as well as extended control field. Okay, we had discussed the frame format of HDLC frame. In that, we had seen that address bit is of 8 bits. So if it is of 8 bits, the total number of addresses that it can have is 2 raised to 8, that is 256. Okay, maximum number of addresses. And then we had said that this addresses can be increased also if required. Also, at the start of this, when I was discussing this HDLC, we had discussed that the maximum window size can be 7 or it can be 127. We'll see how from 7 it can go to 127. Okay. Now, if 3-bit numbering scheme is used, it is maximum window size is 7, and if 7-bit numbering scheme is used, it will go to 127. And this is very simple. Okay. So we'll discuss this separately. First is addressing. Extended addressing. Okay, addressing capability of HDLC can be enhanced using a technique called as multi-octet addressing scheme. In this addressing scheme, the address field, this is the address field. Okay, is recursively extended using the first bit of each octet to indicate the extended format of the address field. The first bit, now this bit, the first bit of each address octet is set to 0, indicating that the next octet is also considered to be part of the address field. Okay, in the last octet, in the final address octet, the first bit is set to 1. Now this is very simple. It is like to increase your addressing. Now what happens is that we have one octet. Okay, this is the address field. Okay, if this bit if the first bit is 0, it will tell the receiver that the next octet is also to be considered as address field. Okay, and then again if it is 0 in the next octet also, first bit is 0 in the next octet also, so the next to next octet also to be considered as address field. In the last octet, what they do, or in the last what do you say, final address octet. Okay, yeah, the first bit is the one telling the receiver that now this is the final address octet. Okay, so the first bit of every octet is important. If it is 0, next octet is address, and if it is 1, then this is the final octet. This is how address field can be increased. Okay, this is very simple. And next is extended controlled field. Okay, now there in the previous in this control field, which was that we had studied, it was of 8 bits. Okay, and then we had I frame, S frame, and control bits, format control field for I frame, control field for your a supervisory frame, control field for unnumbered frame. It was of 8 bits, and then you had seen there NS, which was there, or it was of 3 bits. So actually it was using 3-bit numbering scheme. That's why 8 bits of control field was enough. But if you want to increase the window size, what you have to do is that you have to this control field increases to 2 octets. Okay, so first, whenever this is a control field for your I frame, so how do we understand that it is control field for the I frame? Because it is starting with 0. Okay, next, what was there? It was the frame number of the I frame, that is NS. In the previous example that we have seen in the previous slides, in the previous videos also, we have seen that this was only of 3 bits NS, because it was using 3-bit number scheme. Here we are using 7-bit number scheme, so this field is extended. Okay, so it is of 7 bits. Then we have pole and final bits, and then we have your RR, piggyback acknowledgement number. So NR is piggyback. So this is also of 7 bits. So it is very simple. From 8 bits it is extended to 16 bits, and with 3 number, there it was 3-bit number scheme. Here we have 7-bit number scheme. It is very simple. Okay, and same thing will happen for your S frame. Okay, again, how do you know it is S frame? Because it is starting with 1 and 1. So we know that it is a S frame. This S and S will indicate what kind of acknowledgement it is, whether it is received ready acknowledgement, received not ready acknowledgement, or your request for its answer reject and SRGJ and all will be indicated using this remains the same as of what we have studied for the previous slides. Okay, and only the difference is that here, since we are using a 7-bit number scheme NR, now whatever acknowledgement it is, this will be the acknowledgement number for this acknowledgement. For example, reject 1. Okay, so since we are using 7-bit number scheme, this also will be increased by 7 bits. It is very simple. Okay, and we don't have we need not extend the control field for your U frame, because it doesn't carry the acknowledgement numbers. Okay, so it remains the same. So this is how we can extend the address field as well as the control fields. Hopefully you have understood this HDLC topic. For any issues, please contact me. Okay.